So far, whenever we've wanted to print something, we've used the methods print and println, and those are fine, and for the most part, they do what we need. They're easy to work with, and they get the job done. Sometimes, though, we want to format our data with a little bit more control, especially with numbers. And so we have a method called printf that gives us a little bit more control. And we're going to look at some different ways we can use it. Okay, so when we talk about the precision of a floating point number, what we're really referring to is the number of digits to the right of the decimal point, and how many are supported by the programming language. So Java supports the type double for numbers that have many digits of precision. So print and println, they don't actually generally display all those digits. That would be way more than we actually see whenever we print a double value. They display however many are necessary in order to convey what the value of the number basically is. Okay, so sometimes we get too many digits, sometimes we get too few. As an example, a whole number might be displayed with a single zero to the right of it, to the right of the decimal point. But in a financial application or a stock ticker or something like that, we'd want to see dollars and cents displayed with two zeros, okay, not just one. So as an example, look at this code segment right here. We have a double called dollars. That has 25. We have a double called tax. It's dollars times 0.125. It looks like 12.5% tax. And we'll print income and tax owed. This is the output we get. 25.0, 3.125. The amount of money on the first line has too few digits to the right of the decimal point, and the amount on the second line has too many. So fortunately, Java includes a method called printf for formatting output. So this code segment modifies the last one and shows what we can do to print out these floating point numbers the way we actually want to see them. The output we get here after using printf is 25.00 and 3.13, two decimal places just as we wanted. You can see it looks a little bit different. The parameters that we pass, or the arguments that we pass in, are a little bit different here. We're passing a string, it looks like, income, and then we've got some funny gobbledygook. And then as a second argument, we're passing dollars, the actual variable that we want to print. Same here, got a string. Inside that string, we've got some gobbledygook, and then the variable that we want to print. Okay, so we ought to give a little more attention to what those parameters are. And the general format for the printf method is a format string and one or more data values that we're going to print. This is the general form right here. As an example from the last slide, this is the format string, income, and then all this stuff. And this is the single data value that we wanted to print. Turns out here we're actually only printing a single value. Okay, the format string is a combination of a bunch of regular old literal string information and some formatting information. Okay, and that formatting information has one or more format specifiers. That's what they're called, format specifiers. That's what that gobbledygook is. And those codes, they start with a %, and they end with a letter that tells us what the format type is. So in our example, our code segment, the format specifier %.2f, it says display a number in fixed point format with exactly 2 digits to the right of the decimal point. Next to it, the format specifier %n says display an end of line character. Okay, so we can see a couple of the common format specifiers right here. Okay, D is going to represent a decimal integer. X for hex. We can see the same for octal. Floating point numbers get F. Exponential notation, to do that, we'll format it with an E. We've got general floating point numbers, strings, and then that end of line we just mentioned. Okay, that symbol %n, we can use it to embed an end of line character in a format string. Okay, so the symbol %% actually makes the literal %sign character appear, because otherwise we wouldn't have a way of telling whether it was the %sign or the start of a format specifier. So if we want to output the data in formatted columns, first thing we have to do is establish what the width of the field is going to be, and then we choose the right format flags and specifiers that we want to use with printf. So the width of a field that contains a double, the width goes before the decimal point in the format specifier f. F for floating point. Remember that. So as an example, take a look here. %6.2f. Okay, that says use a precision of 2 digits, that's what the 2 is, and a field of 6 columns when we're displaying whatever floating point number we're displaying. So the number 4.5, that gets displayed with 3 leading spaces. Okay, that's because 1 column gets reserved for the decimal point, so that's 1 column out of the 5. 2 columns are our level of precision, so that's the 4 and the 5. And then there are 3 out of our 6 columns left over. So those are the 3 leading spaces. We're right justified by default. But if you look at 45,000.5, on the other hand, that's actually bigger than the field that we specified for it. That's bigger than the 6-column field that we had said we were going to use. So it ends up not getting right justified. It ends up left justified. In general, if the width of the field is less than or if it's equal to the string representation of the number, when the width of the field is less than or equal to the string representation of the number, the string ends up getting left justified. And that same rule is in place when the field is totally omitted before the decimal point. So if we didn't even include 6 at all, if it was just %.2f. It's a good idea to make sure that the field width for the data is large enough to actually hold the data we want to have. Another example is if we had a format specifier %10s, %10s. That means use a field 10 columns wide to display a string and right justify it. We know it'll be right justified because we haven't specified it'll be left justified. But for the left-hand column of a table, usually we want the strings to be left justified. So to do this, we use the format flag hyphen, like we saw on the last slide, in the format specifier. So we'd end up with %-10s. And that means use the left justification when filling the columns for the string. So we can take a look at some examples here with values 34 and 56.7. Okay, looks like we're doing %d and %7.2f. So %d, we're not specifying a column width. %7.2f, we're saying 2 digits of precision, 7-digit column. Okay, so that means we'll get the 0.70. In total, that'll be 7 digits for the 56.7, and then we'll display 34 as it is. Here, a little different, we are specifying the column width for 34. So those 2 digits of the 34 get displayed, and then we have to fill it up with 2 more leading spaces in order to get it to 4 columns wide. And you can see the 56.70 stays the same. Here, we're saying actually keep it all the same, but except this time left justify the 34. That's what adding that hyphen in does. It left justifies the 34, and we're also adding in a $sign right here. But remember that $sign comes before the column for 56.70, so we've got this gap between 56.70 and the $sign itself in order to get to 7 columns. Okay, and here, last thing we're doing differently, we're not specifying that it has to be 7 columns. We're just going to let it take up whatever it takes up, and that gets rid of this gap here. Immediately after the $sign, we start the number itself. Okay, so we're going to take a look at a program that puts all these ideas together, and it displays a formatted table of data that currently lives in 2 text files. And the first file has the names of a bunch of employees. The second file has their salaries, and the program is just going to assume that the 2 files are the same length, that those names and salaries correspond to one another, and that no one's name exceeds 15 letters, and no salary is larger than 6 figures. So this is an example of what it's going to look like. Barker, Lambert, Osborne, 4,000, 36,000, 150,000. Fine. Some pseudocode for what we're going to do. We're going to open the file names, open the file of salaries. Okay, we're going to print our header, and then while there are more names in the file of names, okay, read a name, read the salary from the salaries file, and just output the formatted line of both. It's not rocket science. Let's take a look. Okay, now, in order to get the formatting to look the way we wanted, we have to left justify the header and each name within 16 columns. We want to left justify the header and each name within 16 columns. To format the salaries, we want to right justify the header in 12 columns. And each salary, we give it 12 columns of width and 2 columns of precision. 12 columns width, 2 columns of precision for that numerical salary data. The 2 columns of precision are just for the decimal, in case there are any senses, in case there are any cents in the salary. So here's what the code looks like. Okay, we've got our import statements. We're using a file, so we've got java.io.star. We're using a scanner. Look, here's our scanner. It's going to read this file names.txt. This one is going to read salaries. So we have 2 separate scanner objects. Then we print our headers. Okay, so let's take a look at this. Left justified 16 column string. And you see there's no hyphen there, so it's a right justified by default 12 column string, and then the end of line. The strings that are corresponding name for the first one, salary for the second one. Now, we were reading in our data while there is a next name, get the next name, get the next salary, and print. Again, here we've got a left justified 16 character string and it looks like there's no hyphen, so it's going to be by default, it's going to be right justified 12 column floating point number with 2 digits of precision and commas. We're going to include comma separation in the number, and then the end of line character. So that's going to be name and salary. And that's going to do the job for us. Open up those files when you get a chance and run the code yourself. One last thing, we can actually use the string method called format. So this is a static method in the string class. That's why we're calling it with the name of the class itself. We can use the string method format to build a formatted string. So it takes the same parameters as printf, and it just returns the final formatted string. So the example here is, if we do string.format income % comma point to f, okay, so that means give me a right justified number with comma separations, no specified number of columns, but 2 digits of precision for this floating point number. It's going to take this number, which is 2,500,000, and it'll return this string formatted nicely for us. That can be helpful if you don't necessarily want to use system.out.printf. You can format the string, stick it into a regular old string variable, and then print it or println it just the way you would like. Before you close up shop, here are the big things. You want to be able to write format strings, okay, including the format specifiers and the format flags to print any of these things. Left justified text, right justified text, text with a specified number of columns, numbers to a specified precision, numbers with commas, leading zeros, all those things in the chart. And you want to be able to write the values that are returned by an expression, including a call to string.format. So you want to be able to use string.format to actually get formatted strings that we could print and store as we'd want. I don't expect you to memorize these format flags and don't necessarily expect you to use them all the time, but it's one thing we want to have in our bag of tricks.